All right, guys, we're going to work on this worksheet here together. And like I've probably already mentioned to you, if you know what you're doing, guys, I would probably do 3 or 4 at a time and then just come back here and use it as an answer key. Come back and check your answer. There's no reason for you to watch the whole video if you know what you're doing. But that's only if you have an exact idea of what you're doing here. So the first thing I would probably do, if it's not already right in front of you, I would write down the 5 ways to prove triangles are congruent. So it's like right in front of your face. So there's the 5 ways to prove triangles congruent: side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg. It only works for right triangles. So let's just start with number 1 here. And you see those 2 triangles, they already have one side marked congruent in both triangles, and they have another side marked congruent in both triangles. So that means it either has to be side, angle, side, or side, 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 since we already have 2 sides that are congruent. But you'll notice the angle that's congruent, and the key for this, for side, angle, side to work, guys, is the angle that is congruent has to be the included angle between those 2 sides. If it's not the included angle between the 2 sides, then side, angle, side will not work. So those 2 triangles are congruent by side, angle, side. Now we just need to write a congruent statement, and we need to match up all the vertices with one another. So X matches up with D. Y matches up with point B. And then Z would have to match up with point E. So triangle XYZ is congruent to triangle DBE by side, angle, side. All right, so number 2, there's just a little bit more work to start this problem. They've marked 2 angles congruent, but if we look up at our 5 angle theorems, there's no AA. So we need to make sure there's nothing else we can mark. Notice QS, both of those triangles have the side QS in common. So they both do have a side that's congruent to one another. QS is congruent to QS. So since those segments are congruent, we have 2 angles and a side. So we know it's either AAS or ASA. It all depends on which side they give us. Well, the side they give us is the included side in between the 2 angles. So since it's in between the 2 angles, these triangles are congruent by angle, side, angle. And then there's the rest of your answer. Point P matches up with point R. Point Q matches up with point Q. And point S matches up with point S. Number 3, the same thing applies to number 3 as it did to number 2. We should see immediately that these 2 triangles share a common side. They both have segment AC in common, so segment AC is congruent to itself. So it should be pretty clear why these 2 triangles are congruent. They have 3 sides that are congruent with another, so the triangles are congruent by side, side, side. And then just make sure we match up the vertices correctly. A matches up with itself. Then we look at B. B matches up with angle D in the other triangle. And then angle C matches up with itself as well in this problem. All right, and then number 4, we've got 2 parallel lines right here. Remember, that's what that symbol means, those little arrows right there. It means those 2 lines are parallel, and they are being cut by a transversal right there. So from our last chapter of study, we know that this angle is congruent to this angle because they're alternate interior angles. So we know angle R is congruent to angle T, but those parallel lines are also cut by this transversal, segment SP, so we know that angle S is an alternate interior angle with angle P. So angle S and angle P are also congruent. So now we really could stop. We have enough information to prove the triangles are congruent, but some of you may notice that we have one more pair of angles that are congruent. Right here in the middle, these are vertical angles, so they're also congruent. So now we have 3 angles that are congruent. Again, there's no AAA, but there is an angle side angle, and there's an A angle side. So we can prove these triangles congruent by either one of those. Because we have an angle, another angle, and then a side. So that's angle, side. But we also could prove the triangles are congruent by angle, side, angle. We have an angle there, we have another angle here, and we have the side in between them is congruent. So those triangles are congruent either by ASA or AAS. Either one of those would be correct. So then just match up the angles. Angle O is congruent to itself. Then we look at angle S. Angle S is congruent to angle P. And angle T is congruent to angle R. So that's our full answer on number 4. Number 5, the only thing they've given to us is both of those triangles, triangle CER and LRU. They both have a right angle, so they do both have an angle in common. They do not have a complete side in common. Angle CER has this side. The other triangle, though, has that side plus a little bit more. So they don't have a complete side in common. They don't have vertical angles, so there's nothing else we can mark here. So we do not have enough information to say those triangles are congruent. So we just say not enough info, not enough information for this problem. All right, number 6. In this problem, we have a side. They both have a side there. They have another side right here. And they have the included angle here and here. That is in between the two sides. It's the included angle between those two sides. So these triangles can be proven congruent by side angle side. And then just make sure you match up the vertices correctly. Angle A and E are congruent. So those match up. Angle G and angle... So angle G is congruent to angle F. And then finally, angle T is marked congruent to angle N. So that's our answer for 6. All right, number 7, you should be seeing problems like this quite often now. You should be able to mark some additional information here. Both of those triangles share a common side, segment WY. So they have that side in common, so WY is congruent to itself. So these triangles can be proven congruent by side, side, side. And if you have trouble identifying what angles are congruent, look at the segments. So this one starts off with WX. If you look up here, WX has one hash mark through it. And the other triangle, the side with one hash mark through it, is WV. So if that one started with WX, this one should start with WV. Of course, the last letter has to be Y. Number 8 can be a tricky one. Again, they share a common side right there, segment GJ, but there isn't really any more information we can tell by looking at the diagram. This looks like a 90-degree angle, sort of, but they don't tell us it's 90 degrees, so we can't assume that that's a 90-degree angle. So just looking at that diagram, there's really nothing else we can mark congruent. So again, we don't have enough information on number 8. And again, if we're going too fast, just make sure you pause so you can get everything written down and understand everything as we go along. Number 9, if we just look at this diagram as it is, we don't have enough information. However, if you remember from last chapter, you should be able to identify 2 angles that are congruent because they're vertical angles. Angle AYD and angle WYF are congruent. So now once we mark those angles congruent, we should see pretty quickly that we have a side, and a side, another side, and another side, and in between those two sides we have the included angle is congruent. So these triangles are congruent by side, angle, side. And then there's the congruent statement. Triangle ADY is congruent to triangle WFY. If you're still having trouble coming up with that congruent statement, again, just take one piece at a time. For instance, look at DY in the diagram. In the diagram, segment DY has 2 hash marks through it. Well, it should match up with segment FY in the other triangle. In the other triangle, segment FY also has 2 hash marks through it. So that's a way we know we have written the congruent statement correctly on number 9. Moving forward, number 10, we again have vertical angles. So our vertical angles are congruent. So we have 2 angles. Since they both have a 90-degree angle, we know those angles are congruent. We have 2 angles and we have a side. The side is in between the given angles. It's the included side between those 2 angles. So that means these triangles are congruent by angle, side, angle. Please let me know if you're having trouble distinguishing between ASA and AAS. Those are the 2 that are mixed up often the most. So our congruent statement, angle X is congruent to itself. And then segment XY is written next. So segment XY is congruent to segment XP in the other diagram. And then point Q comes last. So again, we're going to move to the next sheet. Pause if you need to get everything written down. So we've got some more of the same here on worksheet number 2. Worksheet number 2, we've got 2 triangles once again. Everything is marked for us, and it should be pretty clear. We've got 2 angles here, and we've got the side that is in between the 2 angles. So these triangles are congruent by angle, side, angle. Here pretty soon I think we will have an angle, angle, side, so you can kind of tell the difference here in a second. So then write our congruent statement, triangle JKL. Well, point J has to match up with point M because they're the only 2 that don't have an angle marking. Point K matches up with point N. And point L matches up with itself. Number 2, again, we've got vertical angles. You should see that coming up quite often in these problems, so always be on the lookout for vertical angles. They're congruent. That's enough information to prove these triangles are congruent by side, angle, side, since the angle is in between the 2 sides. And then just match up your vertices. So point P matches up with point T, point Q matches up with point S, and R matches up with itself. So those are 2 triangles that are congruent on number 2. All right, so finally one that's a little bit different. Number 3. Number 3, again, we have 2 angles. We know this angle is congruent to this angle, and we know this means 90 degrees, so these angles are congruent. However, the side they give us is not the included side. The included side in these 2 triangles are segment HG and segment BC. Those are the 2 included sides, but they don't give us that information. They give us that segment GF is congruent to segment AC. So what we have is we have an angle, and then another angle, and then a side that's congruent. So that is angle, angle, side, the reason those 2 triangles are congruent. So just match up the vertices. Vertice F matches up with vertice A. Vertice G matches up with vertice C. And then H matches up with B. So that's our answer to number 3. And then number 4, this is the rarely used congruent statement. We have an angle, we have a side, and then we have a third side. So that is angle, side, side. I'm not even going to write the second S there. And we talked about how that's not one of our 5 congruent statements. But these 2 triangles we actually still can prove are congruent, and that's because of hypotenuse leg. This one's not used that often, but it only works for right triangles. The hypotenuse, remember, is the longest side of the right triangle. So that's segment RS is congruent to segment LK. So the hypotenuse is congruent in both of these right triangles, and they also have one of their legs that are congruent to one another. So since it's a right triangle, we can use hypotenuse leg to prove these 2 triangles are congruent. This one is one that's not used often, but anytime you see a right triangle, HL is a possibility. All right, number 5 we've seen so many times, I've just skipped right to the answer. That is side, side, side. Since they share a common side, we can mark it congruent. They share segment NO. So that's the answer to number 5. So starting on number 6, it gets just a little bit different. They haven't marked anything, but they do give us some information. So you need to make sure you read that information, and then you can mark the diagram. So angle A and D are right angles. So that's the first thing I'm going to do. I'm going to mark those 2 angles congruent with a little box. So those are both 90-degree angles. And they also tell us segment AB is congruent to segment DE. And then finally, segment AC is congruent to segment DC. So now we can say those 2 triangles are congruent. They are right triangles. We cannot use HL here if that's what you're thinking, because remember, to use hypotenuse leg, you have to know the longest side of the triangle is congruent to the longest side in the other triangle, which we do not. Instead here we just have side, angle, side, because the right angle is in between the 2 congruent sides. Going forward, it's the same thing. We need to mark the given information they give us. So go ahead and mark that information on number 7. Segment WS and WU are congruent, and also segment UT is congruent to segment ST. Make sure you're using the double hash marks to differentiate so that you know that TU is congruent to ST. And if you do 1 hash mark for every side, it looks like all 4 sides are the same length, and that's not the case here. And then it should be pretty obvious they share a 3rd side, so these 2 triangles are congruent by side, side, side. Make sure you got that congruent statement right. That one's a little tricky if you're not careful, because a lot of the sides look the same. Just make sure, for instance, segment ST has to be congruent to segment UT. Has to be written in that order, because ST has 2 hash marks through it, and so does segment UT. So that's a good way to check how you've written your congruency statement. All right, number 8. So number 8's a little tricky. It gives us a couple different things. It tells us WX is parallel to ZT. And it also tells us segment XT is a bisector of segment WZ. So if XT bisects WZ, that means it cuts this segment from W to Z into 2 equal pieces. It means it's cut it right down the middle. So that tells us segment WV has to be congruent to segment VZ, because it's been bisected. We have looked at a problem with parallel lines already. So again, if you can't see it, notice you got 2 parallel lines and they're being cut by this red transversal basically here. So that tells us that this angle and this angle are alternate interior angles, because they're being cut by a transverse. They're 2 parallel lines. 2 parallel lines are forming those angles, and also that transversal. The same can also be said, again, with those 2 parallel lines, they're being cut by this transversal. So those are the 2 parallel lines. Again, we have alternate interior angles here and here. So alternate interior angles we know are congruent. So now we're given that amount of information, we should be able to prove the two triangles are congruent. So now think, given that information that we have, what reason are those triangles are congruent? We have an angle there, an angle there. We've got another angle, and then we have a side. So we have an angle, and then a side. It's not the included side between those two angles. So those triangles are congruent by angle, angle, side. And there's the congruent statement. Triangle VWX is congruent to triangle VZT. Just in case some of you didn't do this, which is you could have, there are vertical angles in this problem too. So if you found those two vertical angles, you could have possibly also used angle, side angle. There were two ways actually to prove those two triangles congruent. But if you didn't see that, don't worry about it. Let's move to number 9. Again, I encourage you to pause the video. Go ahead and try yourself. If you haven't already, mark the information first before I do it, just to make sure you feel comfortable doing it on your own in preparation for a quiz or a test we may be having. So that should be the information you should be able to mark. Just looking at that, that's not enough information, but you should be able to identify vertical angles right here. So now you should see those two triangles are congruent by angle, angle, side. It's not ASA. This is not angle, side, angle. Because the side they give us is not the included side. Like this would have to be the side they give us if it's going to be angle, side, angle. So triangle FOX, F-O-X, should be congruent to triangle B-O-D by A-A-S. Try number 10. Again, pause the video. Try to mark everything you can given this information right here. Just in case you do not know, this little upside down T, I'm going to mention this in class today, but that means those segments are perpendicular. And perpendicular, of course, means they form a right angle. So segment XY is perpendicular to segment AY. So since those two segments are perpendicular, it means that is a 90-degree angle. Secondly, they tell us segment BA is perpendicular to segment AY. So again, it means this angle right here is 90 degrees. Then it also, a little more straightforward, XZ is congruent to segment BZ. And then lastly, it tells us Z is in the middle of segment AY. So if it's in the middle of this segment right here, it means it essentially is cutting it into two equal pieces if it's directly in the middle. So that means this piece, YZ, is congruent to this piece, ZA. That's an 8, not an A. And now looking at that, decipher whether those two triangles are congruent. There's nothing else we can tell. We don't have vertical angles in this problem, but we can prove these triangles are congruent. If you look at all your theorems, there's no theorems that have an S and an S and just one A. There's no ASS. But since both of these triangles are right, that means HL is a possibility, the hypotenuse leg. The longest side of both triangles are congruent, and they also both have a congruent leg. So these triangles are congruent by HL. triangle XYZ is congruent to triangle BAZ. All right, so those started to get a little more challenging there towards the end. Again, we will go over some of these tomorrow as a class, but let's go ahead and flip to the final page and see how many of those we can do. All right, worksheet number 3. Again, it should be pretty obvious what we can do first. They share a side. So since they share a side, they have that in common. It's congruent. So then look through your 5 different possibilities of answers and decipher which one of those it is, or of course not congruent is an option. I really like the answer not enough information, but either of those could work there. But these triangles are congruent. They're right triangles, and we have the longest side, segment DF, is the longest side of both of those right triangles. So that's the hypotenuse of both of the right triangles. And they also have a leg that is congruent. So those triangles are congruent by HL. So triangle BDF is congruent to triangle CDF. Hopefully you're getting to the point where you're starting to notice vertical angles a little easier. So angle GOH and angle FOL were congruent because they're vertical angles. Then we can prove those triangles are congruent by angle, side, angle. The side that is congruent is the included side between those two angles. And then there's your congruent statement. Triangle GHO is congruent triangle FLO. Number 3, no need to write anything in. Those triangles aren't touching, so it's hard to decide, provide any more information there. But we've got enough. We got an angle, and then we've got a side. In that order: angle, angle, side. So those triangles are congruent. And triangle PQR is congruent to triangle UTS. All right, skip number 4. I feel like that's one you can do at this point. Number 5, these are not right triangles. They look sort of like right triangles because angle T and angle R look like they're right angles. But again, we can't assume that. So since we can't assume that, the only information we have is we have an angle and we have 2 sides. And there's no such thing as angle, side, side. That does not exist. So those triangles are not congruent, or at least we don't have enough information. You can say not congruent, or you can say not enough info, either one. Again, I encourage you, if you're following along, just pause. I'm going to give you answer number 6 here in a second. Really, the next 3 problems you should be able to do pretty quickly. There's your answer number 6. Be careful, just because they are right triangles doesn't mean HL is going to be the answer. We have side, and then the angle that is congruent is in between. It is included between the 2 sides. Final couple. Again, I skipped a couple, but number 9. Try number 9 if you haven't already. We've got 2 right triangles. Should recognize that those 2 triangles are congruent by HL. They're right triangles. The longest side, the hypotenuse, is congruent with the other hypotenuse, and then one of the legs is congruent with one of the legs in the other triangle. So those 2 triangles are congruent by HL. I'll let you fill in the congruent statement. And then finally, number 10. Again, there's some information we can mark. I don't see anything else that we can mark here, though. There's no vertical angles in this problem. There's no parallel lines. There's no right angles. So all we've got is an angle and just one single side. So that's not enough information. All right, that's it. Make sure you have this finished. Come with questions tomorrow. If something was not crystal clear, we can go over it before our daily assessment.